Hello everyone, today I am in the soil physics lab of Low Carbon Center at the Ohio State University, and in this video I'll show how to measure soil bulk density using the core method including core fragment correction. Let's talk about the concept of bulk density. Bulk density is the oven dry mass of soil per unit total volume. When soils contain gravel or coarse fragments, a correction is required to obtain accurate bulk density. The materials that we require: a metal soil core of known volume, a core sampler or hammer, a knife or spatula, plastic wrap, aluminum moisture tins, a balance, and a 2 mm sieve, and an oven set at 105 degrees Celsius. The first step is collecting the undisturbed core. An undisturbed soil core is collected by inserting a metal core vertically into the soil, minimizing disturbance. Step 2 is trimming the soil core. Excess soil is trimmed from the top and bottom so the soil is flush with the core edges, preserving the exact core volume. Step 3 is wrapping the core. The soil core is wrapped tightly with plastic wrap to prevent moisture loss and preserve structure before further processing. Step 5. Wetting and drying. The soil sample is wetted, then oven dried at 105 degrees Celsius for 24 hours to obtain the oven dry mass. Step 5. Separating coarse fragments. After drying, the soil is passed through a 2 mm sieve. Material retained on the sieve is considered coarse fragments such as gravel. Step 6. Measuring coarse fragment mass. The coarse fragments are weighted separately to determine their dry mass contribution. Step 7. Coarse fragment volume correction. We use a measuring cylinder for doing that. The volume occupied by the coarse fragments is calculated using an assumed particle density, typically 2.65 grams per cubic centimeter. Step 8. Bulk density of the fine earth fraction is calculated as corrected bulk density equals oven dry mass of fine soil divided by the total core volume minus coarse fragment volume. Why this correction matters? Let's talk about it. Without coarse fragment correction, bulk density can be overestimated, particularly in gravelly or stony soils. So this is how soil bulk density is measured using the core method with coarse fragment correction in a soil physics laboratory. Thank you so much for watching this video.